This conference will now be recorded.
Hello.
Hello, are you able to hear me?
Yes.
Hello.
Hello.
Are you able to hear me?
Yes.
Okay. Okay. So what is our last session?
About
What is our? I think we have discussed about data loss principles, isn't it?
yes. Okay.
So next topic is dimension modeling.
Mhm.
So what is dimension modeling? So designing of database structure as per warehouse perspective is called as a dimension modeling. Dimension modeling is done with two type of objects or two type of tables. What are those means? Dimension object and fact object. So complete warehouse is designed only with these two type of components. So for example, if your warehouse is a database, then dimension is a table, fact is a table. If your warehouse is a file system, then dimension is a file and a fact is also a file.
Okay.
Dimension. So in general English, What do you mean by fact?
Like a fact value. And that
In general English perspective, fact means truth, reality.
Mhm.
So that means this fact talks about reality of the business, truth of the business. That means the business is success or failure. So when you can say business is success or business is failure, if they got profit, it is success. If they got loss, it isn't failure, isn't it?
Yes.
So profit and loss, what type of data it is? Means it is like numbers, isn't it?
Yes.
So with the help of that numbers, we can know whether that business is having a profit or loss. That means the business is success or failure.
Yes.
So numbers are helping to know whether the business is success or failure.
Mhm.
So fact is a numeric field. It is a numeric field.
Mhm.
Usually we'll call this as a measure. Usually we'll call it as a measure. Fact is a measure.
Mhm.
So fact is a measure used to measure the business. Fine. For example, I'm having some data in this way. 101, name is Smith, 1000, 102, Allen, and for example, 2000, something like this, some data is present.
Mhm.
So what is whose data it is?
Business data.
Okay, to which entity it is belonging? So at present, we cannot tell that to which entity it is belonging. It may be an employee's data,
Mhm.
maybe it is a customer's data, maybe it is maybe some other type of values. So it doesn't have the clarity exactly to whom this particular data is belonging.
Mhm.
So we want to have a better information for this. Sorry, 1 minute, I typed it wrongly.
Okay.
I'm having something like this: 101, 1000, 102, 2000, and 103, 1500. So what is this data means? We can see it is a numeric data, but whose data means we don't know about that, isn't it?
Yeah. Yes.
So if I say here employee number, maybe this is a salary, then I'll understand that this is an employee data, isn't it?
Yes.
Now, among these three records, I'm able to know that 102 is having highest salary. But who is that person?
Yeah, we
That
don't know.
related information is not available here.
Mhm.
So to explain to which entity this data is belonging, that is provided by the dimension object.
Mhm.
Okay.
Yes.
So before going to that, I'll make small change in these definitions also. Here, this fact and dimensions, maybe we may use with a different context. One context is with respect of table, and sometimes you'll take in the context of column. Okay.
Okay.
So fact column is a numeric field. Fact column is a numeric field. Usually we'll call it as a measure. And where these columns are present means in a table.
Okay.
So that is called as fact object. fact object consists facts or fact columns. Okay.
Okay.
So what is a fact column is it is a numeric field. Such type of numeric fields you may have more than one in the fact object. Clear?
Yes.
But this is not explaining to whose this data is belonging. To
Right.
explain about that, we are having a dimension object. But in this dimension, again, we will take a context with respect of object. Sometimes you may take with respect of column perspective.
Mm-hmm.
So dimension column is used to or is a descriptive column. It is a descriptive column which is explaining about the entity. Okay.
Okay.
Like maybe employee name, customer name, product name, something like that.
Okay.
So it is a descriptive column which explains about whose measures you are maintaining. That means what is the fact you're having, that fact to whom it is belonging is explained by the dimension. So dimension object consists dimension columns, means descriptive columns. For example, I'm having a dimension object in this format, d underscore employees. And here I'm having some fields within this. For example, something like employee number, employee name, next address, date of joining, like different type of fields may be there.
Mm-hmm.
So all these fields are about talking about the entity whose data it is explained with these particular fields. Okay.
Yes.
So for time being, I'll take something like this: employee number, employee name, date of birth, and date of joining. So to understand that this is the dimension object, I gave the prefix as d underscore. So in work environment, the tables may be prefixed with the type of that table, maybe by saying the dimension or maybe fact. Sometimes you may not have any name for that. Okay.
Okay.
So for example, I'm assuming in the period of December 2019, two employees are recruited. Two employees are recruited. So the organization is started in the December 2019 and they recruited two employees. Okay.
Okay.
A new firm is started in the period of December 2019 with two employees. So they recruited two employees, I'm saying here. So when they recruited two employees means that information has to be stored somewhere, isn't it?
Right.
So in d underscore employees table, we are storing that information. So you're having the fields like employee number, next employee name, like certain fields. So employee number is, for example, 101. Employee name is Mark. And I'm trying to take other fields like date of birth, date of joining. So date of birth, for example, I'm saying like 10th of number of, for example, some value. And what is the joining date means? I'm assuming that 01 of December of 2019. Clear?
Yes.
So it is maybe one person data. Similarly, I'm having another person data. 102, name is Mike. And his joining date is, for example, 11th. The date of birth is 11th November of 82, and joining date is, for example, 1st December 19. Like this, some data is present in this particular table.
For the employee number, maybe we need to change 102 instead
Which
of
one?
101. The employee
Yeah,
number.
yeah. I need to change it. By mistake, I wrote 101. So actually, today it's not happening properly, class. 1 minute. So I'm
You're a good
having like
artist.
which whatever.
You are a good artist.
No. So they recruited 2 employees, and this is the data what I'm having. Now, is there any possibility 2 employees can have same name in the organization?
Yes.
Is there any possible 2 employees can have same date of birth?
Yes.
In the organization, is there any possible 2 employees can have same date of joining?
Yes.
Yes. So if everything is same, then how do you identify each employee uniquely?
By employee number.
Yes, you should have a key. So dimension object should consist primary key field. For what purpose means to uniquely identify each employee data, you should have a primary key field. So that's what here we are writing. Initially itself I wrote it actually. So that is what employee number. And this employee number should not be repeated. That is the reason we are saying it is like a primary key.
Yes.
So you're having 101 and here it is 102. Now previously I told that it is consisting descriptive column. So what is the descriptive column? Is the column which is explaining about the entity, like employee name, date of birth, date of joining are called as a descriptive columns or dimension columns. Employee number is basically a key. So we cannot call that as a descriptive column. Employee number is a key. Name, date of birth, date of joining are the descriptive columns or the dimension columns. So this table is consisting both. We are having descriptive columns as well as keys. Okay.
Yes.
So can you have more than one key means? Yes, it is possible. Can you have more than one dimension column, more than one descriptive column means? Yes, it is possible. Already I wrote the 3 descriptive columns. So you can have only one descriptive column or you can have more than one descriptive column also. So dimension object should consist at least one descriptive column and one key. Clear?
Yes.
So you can Sorry, it is not like one key. It can have even more than one key also.
Dimension. Okay.
You can have even more than one descriptive column key also. At least one key column. Clear?
Yes.
So sometimes you may have more than one key. We usually will call such type of thing as in composite keys. So indirectly, I'm saying that both are mandatory. I'm saying as a one descriptive column or one key. That means both are mandatory fields. Clear?
Mm. Yes.
Dimension object or dimension columns and keys are mandatory. So at least one key column and at least one descriptive column should be there. That means indirectly I'm saying that they are mandatory fields. You can have more than one also if you need.
Okay.
Next. In the organization, is there any possibility that particular employee, like for example, Mark, does his key will change in that organization? He is
No.
recruited with the ID called as 101. Later, is there any possibility that number will change?
No.
No. Fine. Is there any possibility that employee name will change?
Yes.
Like 101 Mark is there. Does it happens like 101 David, something like that? Does it happens anytime like that? Is there a possibility that name will
Mm,
change for that same employee?
I don't think so.
Okay. Does the date of birth will change?
No.
Date of joining will change?
No.
No. So except employee name, you are saying that remaining fields are fixed values.
Mm-hmm.
That means we can say they are non-volatile columns, isn't it?
Yes.
So dimension object consists non-volatile columns or non-volatile fields. Okay.
Yes.
Instead of saying dimension object, I'll say dimension columns. Dimension columns are non-volatile. Okay.
Okay.
That means they are not allowed to make any changes. They are fixed values. Because already we mentioned that employee key is not changing, date of birth is not changing, date of joining is not changing. That means they are read only. So that's what I said as a non-volatile.
Okay.
So in another way, to that particular employee, those are the current data at any point of time, isn't it?
Yes.
Dimension object will maintain current data. So here next I'm saying dimension columns are non-volatile because the data is not changing. So it is the current data as well as we are saying it is read only. Clear?
Yes.
Next, dimension objects are denormalized. Dimension objects are denormalized. Okay.
Mm-hmm.
That means related data is kept in single table instead of multiple tables.
Okay.
So these are the general descriptive specifications, but along with that, I'll try to take some other points also. For example, I'm assuming that this organization is started in the period of December 2019 with 2 employees. So
Yes.
in December 2019, how many records will present in this table?
2.
2 records. For example, I'm coming to the January month of, for example, 2020. I'm assuming that organization has not recruited any employee. They're working with the same employees. If I
Yes.
say like that, then how many records will present in this table?
Same
Total
2
number of
or
records present in the table. Yes, it is 2 records. For example, February month of 2020. So still I'm assuming that organization has not recruited any new employees. They're working with the same employees. If I say like that, so how many rows will present in this table means still it will be 2 records, isn't it?
yes.
Now, is there any possibility that in the organization everyday basis they'll recruit the employees?
Maybe.
Every organization will do like that?
No.
No. So they will, like if you take an IT sector only, if they got a new project, then they may recruit a new employee.
Right.
Otherwise, they'll try to work with an existing employees itself, isn't it?
Yeah. Yes.
So until they recruit a new employee, the new data will not come into this table, isn't it?
Right.
That means occasionally they may recruit the employees. That means occasionally the new data will come into this table. That means this table will grow slowly, isn't it?
Right.
Dimension object grows slowly. Because every like if you are assuming that the recruitment until the recruitment is happened, the new data will not come, and until you recruit a new record or new records new employee recruited, the size of the table will not increase. So it will be constant most of the time period. Okay,
Yes.
so these are the specifications of dimension. Now previously you told that in name there is a possibility the employee name will change. Yes, definitely there is a possibility. Some people may change their name, but it is not like every employee, isn't it?
Right.
So we are saying that they are mandatory, but theoretically, in the practical environment, there is a possibility that fields may have some changes. Okay, that values
Yes.
may be keep on changing.
Okay.
So if the values are keep on changing, then how can you see it is a current data? It may not be possible, isn't it?
Yes.
So if you say that it is a current data, the old data will be lost, isn't it?
Yes.
Next, even denormalized also will say theoretically.
Okay.
So maintaining current data, that is theoretically will say like that, but there is a possibility that data may change. If data is keep changing means maybe in some cases I will remove the old data and I'll maintain the new data. But in some cases I'll have the old data as well as new data. That means it may have the current data as well as an historical data, both. Okay.
Okay.
So theoretically, we'll say it is a non-volatile and maintains current data and denormalized, but in the practical environment, you may not follow these 3 steps. There is a possibility. You may follow or you may not follow anything also. So when you come back to the fact, we came to know that fact column is a numeric field, or you can say is a measure. Fact object consists factor columns or measure columns. So for example, I'm having some table like this, F underscore salaries. So as there is a fact object I'm creating, so I represented with F symbol.
Okay.
Now here in this, I'm having something called as a basic pay, HR allowance, special allowance. Now, for example, I'm having something like this. Basic pay is, for example, 15,000. HR allowance is, for example, 6,000. And special allowance, for example, it is 4,000. Citizen basic pay, it is an HR allowance, and it is a special allowance. Now there are two employees, Mark and Mike, isn't it?
Yes.
Corresponding to that, I'm having some data here. For example, it is something like 2,000. HR allowance is, for example, 500. And a special allowance is, for example, 1,000. Now, who's basic pay for whom you're having highest value means it is 15,000. But is it belong to Mark or is it belong to Mike?
Belongs to Mark. And of
So we
course,
don't know that whether it may maybe first to first, if you feel it looks like 15,000 belong to Mark, but there is no guarantee.
yeah, because there is no name on it. Yeah.
So you should tell to whom this particular value is belonging, isn't it? So you should have one column for representing that. So I'm trying to take employee number. It need not be on the same name. It can be anything, not a problem. And I'll say, for example, this is foreign key. Okay. So in the dimension object, already I mentioned that I'm having a primary key column. So employee number, what you're creating, this is a primary key.
Okay.
And for that, we are having a reference column called as an employee number in the F_salaries. So that's what foreign key column. That means you should have some relationship between these two tables, isn't it?
Yes.
Fine. Next, for example, I assumed that their organization has recruited 2 employees, and in the month of December 2019, they got salary in the period of January 2020. So, how many records will present in this table now? F_salaries. For example, I'm talking about because I'm assuming that they're getting salary month-wise. So, in month January of 2020, how many records will present in this table?
2.
2 records. Fine.
Yeah.
So when you come to the February month of 2020,
02.
so total number of records will be
2 records.
they will not take salary in February month.
Yeah, monthly basis.
So already they took salary in January. Those records will be there. When you come to the February, it is not like you will delete the old records. So those records will be there as it is, and we'll try to maintain the new data also, isn't it?
Yes.
So that means 2 records of January plus 2 new records of February. Total of 4 records will present.
Okay.
So when you come to the March 2020,
6.
new records of March and belong to January and February 4 rows. That means totally
6.
it is 6 rows. Like this it goes on. For example, if you come to the December of 2020, for example, in such case, how many records will present here? January to November, isn't it?
Yes. December, no.
So that is 22 and 2 new rows of December month, isn't it?
Yes, 24.
That means totally 24 rows will present, isn't it?
Yes.
So every month, 2 new rows are coming into this table. For example, if you feel that there are 10,000 employees are there, that means every month 10,000 rows will come into this table, isn't it?
Yes.
And for example, I'm assuming uh, 10,000 employees are there, and instead of taking getting salary month wise, they're getting salary week wise. That means what will happen? Every week 10,000 records will be added into this table, isn't it?
Yes.
That means in the dimension, is there anything like employees are increasing? Means no, they're working with the same employees, isn't it?
Yes.
That means with the same employees, you're adding the new data continuously. That means its size will increase, isn't it?
Yes.
Or it requires more space.
Yeah.
It grows quickly. Clear?
Yes.
Same thing here also, I'll type that.
Okay.
In the dimension, I'll say that dimension object grows slowly. Okay, already typed it. Okay.
Yeah.
So this table grows very slowly, but whereas fact grows quickly because
Quickly.
every month the new data is coming up.
Yes.
Okay, next. So already we told that it is consisting factor columns or measure columns. Along with it is consisting keys, I told, isn't it?
Yeah.
So I type that column also. Fact object consists. I missed that point previously. Fact object consists a foreign key field. So it will not have any primary keys. Usually have only foreign keys. Foreign key field with respect to primary key column. Primary key column of dimension. Fine. After that, it grows quickly.
Yes.
Next. Fact object or fact column usually it maintains summarized data. The fact object maintains summarized data. Instead of individual values, you mostly will do some calculations and calculated data will present here. Clear?
Yes.
But when you are saying that you are summarizing it, then is there any possibility that you'll have old data and the new data? Means it looks like that every time it is a new data or updated data, isn't it?
Yes.
But depending on the client requirement, sometimes some fields will make it as summarized, some fields will make it as a non-volatile, depending on the requirement. It's not like summarizer means every column will be summarized, nothing like that. Only few columns will be summarized. Okay.
Okay.
And is it a normalized or denormalized? Means it doesn't have any specification related to that. We cannot say that it is a normalized table or we cannot say it is a denormalized table.
Yeah.
Clear?
Yes.
So fact is basically a measure. Fact object grows very quickly. It is consisting a foreign key field and it maintains usually summarized data.
Okay.
But as per our example here, if you take it up, what are these 22 rows and what are these 2 rows? 22 rows are belong to January to November and 2 rows are belong to December. That means it is consisting history and the current data, isn't it?
Yes.
So it consists history and current data. But this maintaining summarize the data, it is consisting history and the current. It is not like for every field. Maybe some fields will have history along with the current data. So sometimes certain fields we every time will maintain summarizer data. So depending on the entity, what type of service you are doing or what type of project you are doing, based on that, that will be decided whether you have to maintain history and the current data or only the summarized data. All those things will be decided before starting the project. Okay.
Okay.
So complete warehouse is designed only with these two type of objects. Both are database tables only if you're working with a database structure, but the way of storing or the type of values what you're storing in these tables are different. So for
Okay.
example, I'm having something like d underscore employees, and this table is consisting fields like employee number, that is in primary key column, employee name, date of birth, date of joining. It is my first dimension table.
Okay.
Similarly, I'm having other dimension tables also, d underscore projects. It is consisting something called as an project ID, which is a primary key column.
Okay.
Next, project domain, maybe project client, something like this. Along with that, I'm having some other components also, maybe something like d underscore stores. What are the fields I'm having means I'm assuming that it is consisting store ID, which is a primary key column. Next, store name, store type, something like this.
Okay.
Similarly, I'm having one more table, d underscore times. In the principles, we were told that every database project should consist a timestamp like that. So I'm trying to take the times table here. So what are the fields means, for example, time ID. Next, I'm having something called as an year, maybe a month, and maybe it is a day. So all these four are the dimension objects: employee dimension, project dimension, store dimension, and time dimension. Clear?
Yes.
And at the center, I'm trying to take some other table called as an salaries. And this table is consisting something called as an employee number of foreign key.
Okay.
Along with that, I'm having something called as an project ID. It is also a foreign key. Next, I'm having something called as an time ID. So this is also a foreign key field. Next, along with that, I'm having some other contents like quantity sold. I'll try to take one more field also, store ID. Fine. So here I'm having quantity sold, amount sold. So we're having some foreign key fields are there, and along with it, I'm having quantity and the amount. That means indirectly we are saying that we are having a relationship between the dimension tables with the help of fact table. So if you design anything like this type of structure is called as an dimension modeling. So is it like only 4 dimensions will be there? Means no. N number of dimensions will consist under the project.
No.
It is not like 4 or 5. Depending on the business requirement, we can have N number of dimension objects within that life cycle or within the project. But
Okay.
what about the fact? Usually we'll have only one fact object.
Okay.
We'll have multiple dimension objects, and usually we'll have only one fact object. So I represent with the 4 plus 1, but depending on the project, it will be decided.
Okay.
Next, data modeling. Data modeling means it is also nothing but designing out database structure only.
Okay.
But that is nothing but dimension modeling. But these dimension modeling are categorized into a set of specifications. Depending on the requirement, try to use it.
Okay.
So what are those specifications, or what type of things are available means something like this: star schema, snowflake schema, and third one galaxy. So this is the next topic: star schema, snowflake schema, galaxy schema. But all these things, do you design it in the work environment? Means no. We are recruited as an ETL developer and Informatica developer means already these tables are ready-made. Simply how to use them. Okay.
Okay.
But when it comes to the warehouse, I already mentioned that there are 3 models like a star, snowflake, and galaxy. But if you create a cube system, if you create any cube, that cube will support only star schema.
Okay.
Snowflake schema and galaxy schemas are not allowed within that.
Okay.
But when you can say that particular model is a star schema or one particular model is a snowflake schema means depending how many dimensions you're having, how the dimensions are interconnected, based on that, that will be decided whether it should be a star or snowflake. So those options will make it up tomorrow. For today, we'll close it here. Okay.
Okay.
So data modeling, I'll continue tomorrow.
Okay. Thank you.
Right then. Thank you.
Bye.